Alright, so to begin the build process, I laid out all of my parts, which you see here. Going from left to right, we have the 1806 motors, the 4045 propellers, the frame, the battery, the receiver, the 4-in-1 ESC, and the NACE32. As you can see, the parts count for this build is very minimal, which greatly helps with its simplicity. Here's a closer look at the parts. This is the FreeSky D4R2 receiver. This is the Nanotech 3-cell LiPo. This is the 1806 3100 kV motor. This is the 4-in-1 ESC, and finally this is the NACE32. So the first thing I did was prepare the frame for building. As I mentioned in the introduction video, the frame is cast from a polyurethane resin and is impregnated with fiberglass. When I received the frame, I wanted to add a little bit of color to it, so I painted the edges and the roll bar with some red acrylic paint. I didn't use anything complicated, just a foam brush and a bottle of paint from Walmart. After painting the edges with the foam brush, there was some overspill, so I took some 500 grit sandpaper and lightly sanded away the spilled over paint. It didn't take very long, with the majority of the time being spent waiting for the paint to dry. The nice thing about this frame is that it sands away very easily and leaves a smooth finish, which will allow for some cosmetic repairs in the future if the frame is ever damaged in a crash. Once the paint on the frame had fully cured, I separated the two halves by cutting the zip ties that hold them together, and then I began my work on assembling the main components of the quad. The first things to go on were the motors. These are pretty small 1806 motors with standard spacing for their mounting holes. These motors, along with many other 1806 motors, match the hole spacing on each arm exactly. I lined the motor up and began threading the bolts that were provided with the motors. The bolts were just the right length so that they passed completely through the arm, but not too long that they crushed the windings inside the motor. I repeated this process for all 4 motors, and for this stage of the build I only used 2 bolts per motor as I didn't feel 4 bolts were necessary just yet. I let the motor wires sit on top of the arm as I didn't want to route them underneath, but later on in the build I changed my mind and you'll see the difference when we get there. Before moving on with the build, I taped down the motor wires so they wouldn't dangle and get in my way. I also took this time to flip the frame over and insert the nylon nuts into the nut traps. I used some masking tape here as well to keep the nuts in place. The next step of the build process involved getting all the electronics together. Now, due to the compact nature of this quad, the electronics were going to be tightly packed. There are definitely some cons to a setup like this, with one of the major cons being improper heat dissipation and risk of electrical shorts or interference between your components. I was aware of these risks, but I felt they fell within my tolerance levels. The very first thing I did was get my nylon bolt and spacers onto the NACE32. I did this so I could get a general idea of how much vertical spacing I would have between my boards when the quad was fully assembled. I took the ESC board and slid it onto the nylon bolts, and then evaluated the spacing between the 2 boards. The next thing that needed to be completed was getting the ESC board properly connected to the NACE32. One of the cables that came with my 4-in-1 ESC was a DuPont cable, and it looks like this. One end of the cable simply plugs into the 4-in-1 ESC, and the other end terminates in standard female servo pins. This cable originally was pretty long, around 6 inches, and I wanted to bring down the length so that I didn't have to tuck away any wires when assembling everything together. I measured out how long the wires needed to be in order to reach from the underside of the NACE32 to the 4-in-1 ESC, while also leaving some slack so the wires weren't under tension all the time. After measuring out that distance, I cut the wires and began the soldering process. This part was a little tricky to capture on camera, but I'll try my best to explain what I did. Starting off with the wires, I cut off the ends and stripped away about 1 to 2 millimeters of insulation. Using some flux and solder, I tinned each of these wire ends. Next, I took the NACE32 and filled in each pinhole I would be using with a small amount of solder. I didn't want to add too much, as this would make it difficult to pass a thin wire through, but it still needed to be enough to make a strong connection. After all the pinholes had been filled, I heated the hole from one end with my iron and pushed the wire through from the other end. I repeated this process for all 6 wires, which included power, ground, and the 4 signal cables for each ESC. At this point, it was also important to compensate for any differences between how the NACE32 and the ESC handled their motor layouts. The orders were almost identical, and the compensation only required switching the last 2 wires from the ESC to the NACE32, which corresponded to motors 3 and 4. As you can see here, I made a small mistake when I initially soldered this together and had the last 2 wires, the yellow and the blue ones, reversed, so I quickly desoldered them and put them together in the right order. After the DuPont cable had been successfully attached to the receiver, I moved the ESC board onto the NACE32 stack so I could see exactly how much space I had to work with. Sliding the ESC board on, I routed the DuPont cable under the NACE32 and plugged it into the ESC board. It had a pretty snug fit while still allowing some slack in the cable. The next major step of the build process was getting the receiver successfully wired to the NACE32. Before I began tinkering with electronics on the receiver, I made sure to bind it to my transmitter, which is a Tyrannus, and make sure everything was working as it was supposed to. Then I started working on the receiver. I unwrapped the cardboard that protects the receiver and exposed the header pins. The first thing I needed to do was remove those pins so that the receiver would have a low enough profile to fit in between the 4-in-1 ESC and the NAS32. For removing the pins, I used a process that has worked for me in the past, but there are probably many other different and likely better ways to do this. I began by using wire cutters to cut the plastic housing around the pins. Sometimes when cutting them, they simply pop right off the pins, and sometimes they stay on. Either way, when they are cut up and disconnected from each other, it makes it much easier to slide them off, which is exactly what I did next. After sliding off all of the housings, this is what you're left with. At this point, I took my wire cutters and started cutting down the pins so that only their vertical segments remained. This was done so that I could remove them in the next step without having to deal with a large pin getting in my way. After cutting down all the pins, this is what remained. Next, for removing the pins, I held up the receiver in one of my helping hands. I took my soldering iron and heated the pin from one side of the board while I used tweezers to pull them out from the other side. The trick I learned here is to make sure you're heating the pin as much as possible and not the board itself. When heating the solder around the pin from one side of the board, the heat sometimes doesn't reach the solder on the other side of the board. So you're left with a pin that's stuck and a board that's getting very close to overheating from the soldering iron. I found that by heating the pin directly, it helps to evenly distribute the heat to both sides of the board in a relatively fast manner so the pin slides out with minimal heat transfer from the iron. After all the pins were out, I had to clear out any leftover solder from the pinholes. Unfortunately, I didn't get any pictures of this part, but it essentially entailed heating the pinholes from one side while holding up a solder sucker on the other. It was a very simple process and didn't take more than 5 minutes to clear out all the pinholes. After that was complete, this is what the receiver looked like. As you can see, it has a much lower profile now, and that will definitely make it easier to fit in between the NAS32 and the ESC board. Now that the pinholes were all cleared out, it was time to start soldering in the wires. Since I was using PPM for this build, I needed to get the receiver into PPM mode. In order to do this, usually a bind plug is used to bind two of the pins together. In this case, I took one of the pins I'd cut off earlier and used it to bridge the two pinholes. I simply took the pin, bent it into a horseshoe shape, and slid it into the pinholes. Then I added some solder to seal it into place. Now that the receiver was set in PPM mode, I went ahead and soldered on the 3 wires I would need to communicate with the NAS32: power, ground, and signal. I used the leftover wire from the DuPont cable as these connections were so short it was easy to make with just scrap wire. I followed the same method I used on the NAS32 for soldering the wires onto the receiver. After that was complete, I added some heat shrink around the whole receiver so that it wouldn't short with any of the other boards. All the major connections had been made now, and all that was left was soldering the wires from the receiver onto the NAS32 and assembling everything together. I wanted to wait until everything was assembled before completing this last soldering step because I wasn't exactly sure at that point where the receiver would be going and how much slack I was going to need. After experimenting with some preliminary layouts, I decided to mount the receiver with some double-sided foam tape to create some adhesion with the board. With the receiver firmly in place, the DuPont cable simply passed underneath it so that I could reach the ESC connector on the other side. I slid the ESC board onto the nylon bolts and connected it so that I could get a feel for how everything was fitting together. Although it was a little tight, nothing was getting strained and I didn't see any problem areas. Now that my receiver was in a permanent spot, I began soldering its PPM outputs to the NAS32. I simply tinned the pads with my soldering iron and attached the wires. I followed up by adding a thin layer of liquid tape to protect the wires around the tight bend of the board. Now nearing completion, the last steps of the build began with getting the ESC board soldered into place. The first thing I had to do was solder in a power cable. I used the JST female connector and soldered it onto either side of a ceramic capacitor. After that was done, I had to go back to the frame and install Velcro because that would be sitting directly below the boards. The Velcro simply loops through each armhole like you see in this picture and then closes in on itself. It's a simple feature and it works very well. After that was complete, I began routing the motor wires underneath each arm for cable management reasons. I had to unscrew and remount each motor in order to do this, so it would have saved me some time if I had made this decision in the first place. I started off with one arm of the quad to make sure everything was working right, and then moved on to all 4. Next, I soldered all the motor wires onto the ESC. I apologize for not having more pictures of this process, but this is what the end result looked like. Any wire switching needed for motor reversal was done underneath the arms, so that when the wires came up and out of the holes, I could solder them just how they were without having to cross them over each other. The final step involved getting everything mounted in one large tower. I placed the NACE32 in an orientation like you see in the picture. If you look closely, you'll see how the arrow on the NACE32 points to the side and not to the front. I did this intentionally for the purposes of making wiring easier, and it can easily be corrected for when programming the flight controller. And this is what the final product looked like after everything had been screwed and bolted down. I took the antenna wires from the receiver and routed them through the armholes, and I added a bit of heat shrink to keep them in place. And that about wraps it up. If you have any questions, feel free to leave a comment in the comment section below or send me a message via my website, and I will try to get back to you as soon as possible. Alright, thanks for watching.